Have you ever wondered how that spoonful of instant coffee in your morning cup got there? From lush, sun-drenched farms to high-tech factories, the journey of instant coffee is nothing short of miraculous. Today, we're stepping inside the world of coffee to explore the fascinating, mechanical, and sometimes magical process of how coffee cherries become the crystallized energy we all know as instant coffee. This is the story of patience, precision, and perfection in every jar. It all begins here, in the tropical belt of the world. Places like Brazil, Vietnam, Colombia, and Ethiopia are global coffee capitals. These lands are home to the coffee cherry, the fruit that hides the prized coffee bean inside. Coffee plants thrive in high altitudes with mild temperatures, rich soil, and frequent rain. Arabica and Robusta are the two main species grown, each with distinct flavor profiles. Arabica beans are known for their delicate and complex flavors, often with sweet, fruity notes. Robusta beans are more bitter, with higher caffeine content, and better disease resistance. Each coffee tree can yield about 1 to 1.5 pounds of roasted coffee annually. Farmers monitor weather, soil conditions, and pests closely to ensure a healthy crop. They often use organic fertilizers, mulching, and shade-grown techniques to promote sustainable growth. Coffee cherries change color as they ripen, going from green to a deep red. This color signals they are ready for harvest. In some regions, cherries can ripen at different times even on the same branch, requiring careful monitoring. Some specialty farms go a step further and use agroforestry techniques, planting coffee alongside other crops to maintain biodiversity and shade, which enhances flavor complexity. In massive plantations, handpicking is too slow. Instead, mechanical harvesters are used to collect ripe cherries quickly. These machines straddle rows of coffee trees and gently shake them, dislodging ripe cherries onto conveyor belts or catchment systems. However, machines also pick some unripe or overripe cherries, so sorting later is essential. Some machines are equipped with vibration intensity settings to minimize unripe cherry harvesting. Modern harvesting combines speed with selectivity, using sensors and optical sorters in more advanced systems to reduce waste. Harvesting efficiency can reach thousands of pounds of cherries per hour. Some regions, like Ethiopia, still rely heavily on handpicking to ensure only the ripest cherries are chosen, contributing to the region's unique coffee profiles. Machine harvesting reduces labor costs, but requires well-pruned, evenly spaced trees. Terrain must also be relatively flat to accommodate heavy equipment. Once harvested, the cherries are rushed to processing facilities. The first step is depulping, removing the skin and outer pulp. Depulping machines work by pressing the cherries against a rough surface to squeeze out the beans inside. It must be done within 24 hours of harvest to avoid fermentation spoilage. The pulp is often recycled into compost or used as fuel in some eco-conscious operations. Some regions even turn the pulp into animal feed or fertilizer. At this stage, the beans are still coated with a sticky mucilage layer that needs to be removed. The quality of depulping affects subsequent processing stages. Proper depulping also ensures more uniform fermentation in the next step. Some smaller farms use manual depulpers, operated by hand crank, which adds a rustic charm and gives more control over the process. Demucilage is a crucial step in coffee processing, done through fermentation tanks or mechanical scrubbers. Fermentation can take 12 to 36 hours, influenced by altitude and climate, with occasional stirring for even results. Natural enzymes break down the mucilage during fermentation, enhancing the coffee's flavor profile. Eco-pulpers offer a sustainable alternative, using less water and friction to quickly strip mucilage. After demucilage, beans are washed with clean water, and some facilities recycle this water to reduce environmental impact. This stage is vital for flavor development. Over-fermentation can cause sour notes, while under-fermentation leaves residues. Anaerobic fermentation is a growing trend, sealing beans in oxygen-free tanks for exotic flavors. This innovative method is gaining popularity in specialty coffee circles, offering unique taste experiences. Clean beans are now spread out on large patios or raised drying beds. Sun drying is traditional and allows gradual moisture reduction. Beans are raked multiple times a day to prevent mold and ensure uniform drying. Protective covers may be used at night or during rain. This step can take up to 2 weeks and reduces the moisture content from around 60% to below 12%. Moisture meters are used to check for ideal drying levels. Some factories use mechanical dryers for consistency, especially in humid regions. These dryers can simulate sun drying while maintaining airflow and temperature control. Proper drying prevents mold and spoilage during storage and shipping. Under-dried beans can ferment further while over-dried beans become brittle. In regions with unpredictable weather, hybrid methods are used. Sun drying followed by final touches in mechanical dryers. Dry beans still wear a parchment skin, which is removed during hulling. Hulling machines crack and peel away this layer without damaging the bean inside. The process involves rotating drums, friction plates, or air pressure separation. In some cases, beans are polished to remove silver skin, though this is mostly aesthetic. Polishing does not affect flavor, but can improve appearance. What remains are green coffee beans, raw, unroasted, and ready for transport. These beans are sorted and graded by size, density, and color. Proper hulling preserves bean integrity, reducing breakage and waste. Quality control teams inspect for defects like black beans, insect damage, or discoloration. These are either discarded or redirected to lower-grade uses. Green beans are hygroscopic, meaning they absorb moisture and odors. That's why storage is crucial. They're kept in jute or sisal bags in ventilated warehouses. Conditions are monitored to prevent mold, infestation, or degradation. Optimal storage temperatures range from 15 to 25 degrees Celsius. Beans can be stored for months, but quality checks are essential. Periodic cupping tests ensure flavor integrity is maintained. Warehouses often have humidity control systems in place. Some beans are stored in GrainPro bags or vacuum sealed for export. High-end suppliers may use nitrogen flushing to preserve freshness. At the factory, the unloading process is fully automated. Robotic arms lift and position coffee bags onto conveyor systems. These robots work continuously and reduce labor strain and injury risks. Barcode scanners identify the origin and type of beans, feeding data into tracking systems for quality control. Robotics ensure traceability, efficiency, and consistent throughput. This data-driven approach helps companies monitor supply chain efficiency and detect any issues early. Some factories also use AI-powered vision systems to identify damaged bags or foreign materials, adding another layer of safety and precision. From tropical highlands to ultra-modern factories, the journey of instant coffee is truly a marvel of both nature and engineering. Each tiny granule in your cup has passed through dozens of hands, machines, and meticulous quality checks, all to bring you convenience without compromising on flavor. Next time you stir that spoonful of coffee into hot water, remember the farmers who nurtured the plants, the workers who harvested the cherries, and the technology that transformed a simple bean into your instant pick-me-up. Whether you like it bold or smooth, black or with cream and sugar, instant coffee is a product of patience, science, and global collaboration. Thanks for watching. If you enjoyed this video, give it a thumbs up, share it with fellow coffee lovers, and don't forget to subscribe for more deep dives into how the world works, one process at a time.